Earth is an incredibly dynamic planet. It is unique and beautiful, but powerful and mysterious. It holds the key to give and take life. Earth is always changing. Climates shift. Global temperatures rise and fall. And the biosphere adjusts accordingly. New environments give rise to new organisms, while others who are ill-prepared for the new terrain are forced to change, or they die out. This is called natural selection, and it is why animals have evolved over time. However, when a species cannot change and is no longer able to survive in the changing conditions, they become extinct. Extinction is the state or process of a species, family, or larger group ceasing to exist. Extinction is natural and occurs at an uneven rate, meaning that Earth goes through periods when the rate is high and many species die off, and times when the rate is low. However, since life began on Earth, several major events have significantly influenced this rate, causing what we know to be mass extinctions. An extinction event is defined as a sharp decrease in the diversity and abundance of macroscopic life on Earth over a geologically short period of time. While some scientists say that there have been up to 20 mass extinctions in Earth's history, today we'll look at what most scientists understand to be the largest and most significant, the Big Five. To begin our journey, we must travel back in time 445 million years to the late Ordovician. This was a time when most life existed under the sea and in shallow water. Trilobites, cephalopods, and other invertebrates flourished in the vast seas that covered the Earth during this time. The supercontinent of Gondwana was moving towards the South Pole. By the later part of the Ordovician, this led to the formation of what was perhaps the largest glacial landmass in history. Earth's sea levels dropped dramatically. Some seas emptied entirely of their water. It came as no surprise then that over 57% of all species were wiped out with the Ordovician Silurian extinction event. Melting glaciers and rising sea levels following this event ushered in an era of change. The global climate stabilized, coral reefs emerged for the first time, and fish evolved in remarkable ways. Fast forward now 75 million years to 370 million years ago, the late Devonian period. By this time, plant life is well underway in its colonization of the land, and life in the Devonian seas is dominated by brachiopods. There was a prominent diversification of fish during this time as well. From the end of the Middle Devonian, there is evidence of widespread anoxia in oceanic bottom waters, and organisms that lived on the seafloor were decimated, especially in the tropics and reef communities. Roughly 50% of all species were wiped out as a result. The Devonian extinction hurt the water habitats much more than those on land. The sponges and corals were the most affected, and no major reef building happened again for thousands of years. Life on land, however, continued to flourish and spread. Based on comparisons between fossil and modern-day plant morphology, the Carboniferous plants resemble those that live in tropical and mildly temperate areas today. Amphibians also began their rise in the time following the Devonian extinction. Jump past the Carboniferous period to the end Permian, 250 million years ago. Known as the Great Dying, this was the largest extinction event in history. The global geography of the Permian included massive areas of land and water. The supercontinent was known as Pangaea. Permian marine deposits are rich in fossil echinoderms and brachiopods. The warm zone spread in the northern hemisphere, where extensive dry desert appeared. Reptiles grew to dominance among vertebrates because their special adaptations enabled them to flourish in the drier climate. In the Permian-Triassic extinction event, a total of 83% of all species went extinct. There is significant evidence that massive flood basalt eruptions from magma output lasting thousands of years in what is now known as the Siberian Traps contributed to environmental stress leading to the mass extinction. Based on the amount of lava estimated to have been produced during this period, the worst-case scenario is an expulsion of enough carbon dioxide from the eruptions to raise world temperatures 5 degrees Celsius. Other contributors to the extinction included Pangaea itself, which was altering ocean currents and creating stark temperature differences between the equator and the poles. It is thought that the long recovery was due to the successive waves of extinction, which inhibited recovery and prolonged environmental stress to organisms. Recent research also indicates that recovery did not begin until 4 to 6 million years after the Great Dying. With that, the Paleozoic era ends and we dive into the Age of Reptiles, the Mesozoic era. Just 50 million years after the end Permian event, the Earth witnessed yet another mass extinction. The organisms of the Triassic can be considered to belong to one of three groups: holdovers from the end Permian extinction, new groups, some of which flourished briefly, and others, which went on to dominate the Mesozoic world. The holdovers included the Lycophytes and Dicynodonts, while those that went on to dominate the Mesozoic world included the dinosaurs. The end Triassic event remains mysterious to scientists, but several theories have been stated. Some say that the gradual climate change or sea level fluctuations during the late Triassic could have caused it. However, this does not explain the suddenness of the extinctions of the marine realm. Others blame an asteroid impact, but so far no impact crater of sufficient size has been dated to coincide with the Triassic-Jurassic boundary. One widely supported theory states that the most likely cause of this was the eruption of the Central Atlantic Magmatic Province. 2 million cubic kilometers of lava spewed out over a period of many centuries, and more than 2 quadrillion kilograms of sun-blocking sulfur was released, which would have caused intense global cooling. Pair this with about twice as much climate-warming carbon dioxide, and you've got a deadly climate roller coaster. By the beginning of the Jurassic, the supercontinent Pangaea had begun rifting into two landmasses, Laurasia to the north and Gondwana to the south. This created more coastlines and shifted the continental climate from dry to humid, and many of the arid deserts of the Triassic were replaced by lush rainforests. Dinosaurs dominated the land and reached their peak in this period as they diversified into a wide variety of groups. The first birds also appeared during the Jurassic, having evolved from a branch of theropod dinosaurs. Marine reptiles inhabited the oceans as well. The Cretaceous period that followed the Jurassic was a period with a relatively warm climate, resulting in high sea levels and creating numerous shallow inland seas. Mammals also lived on land, but were a small and relatively minor component of the fauna. The Cretaceous-Paleogene extinction event occurred about 65.5 million years ago at the end of the Cretaceous period and Mesozoic era. Non-avian dinosaur fossils are found only below the KT boundary, indicating that they became extinct during the boundary event. Mosasaurs, plesiosaurs, and many species of plants and invertebrates also became extinct. There have been several hypotheses regarding the cause of the massive extinction. These hypotheses have centered around either impact events or increased volcanism. Some include elements of both. The current overall consensus among paleontologists is that the primary cause for the extinction was an asteroid impact, which occurred about 65.5 million years ago. Such an impact would have inhibited photosynthesis by generating a dust cloud, which would block sunlight for up to a year. It would also inject sulfuric acid aerosols into the stratosphere, which would reduce sunlight reaching the Earth's surface by 10 to 20%. It would take at least 10 years for those aerosols to dissipate, which would account for the extinction of plants and phytoplankton and the organisms that depended on them. Global firestorms may have resulted from the heat pulse and the fall back to Earth of incendiary fragments from the blast. In 1990, researchers identified the Chicxulub crater on the coast of the Yucatan Peninsula, Mexico, as the impact crater. The crater is oval, with an average diameter of about 110 miles. The shape and location of the crater indicate further causes of devastation in addition to the dust cloud. The asteroid landed in the ocean and would have caused mega tsunamis as well. Now that we've covered Earth's 5 big extinctions, we're faced with one big question. When is the next one? Well, the truth is, we're living it. Currently, the rate of extinction could be up to 140,000 species per year, which is an estimated 1,000 times the historical rate. Our Earth is precious. We do not own it, nor control it. It is impossible to predict the end of humans, which leaves us asking, how much time do we really have?